In this video, we're going to create a motion diagram. And the tools that we're going to use are definitions of velocity as a change in position over a change in time, and the average acceleration, which we know is the change in velocity over a change in time. So what am I analyzing? Well, in this case, I want to take the example of a cart on the ground. And my cart's going to accelerate to the right, and we will see this by the fact that the spacing between the carts at equal intervals of time is getting larger and larger. So now I want to represent my cart as a particle. So I'll extend my origin. My cart starts here, and I'm just placing a dot at the center of the cart. And now that I have my dots, I need to show some form of direction, because I'm not sure in this picture, is it moving to the right or to the left? So I'm going to start where I started my picture with 0, 1, 2, and 3. So now that I can see that it's moving from left to right, I can now connect my dots. And I'm going to use a green arrow. And we notice that the head of my arrow is indicating the direction of motion. So it's also representing the displacement. So between time 0 and time 1, we can see that I moved some distance. So I have a displacement happening over a period of time, and we can see that that is our definition of velocity. So I can label this v0 for velocity 1. Velocity 1, there we go. Velocity 2. Now, how do we show on our motion diagram an acceleration? Well, just as we looked at the change in the position to find the velocity, we need to look here at the change in the velocity to find the acceleration. So let's look at the change in velocity. So I'm going to look at what is the acceleration between v1 and v2. So we can see that if I want the acceleration between v1 and v2, I need to be looking at the change of v2 minus v1. So to do this, I'm going to draw a picture, and I'll have my starting point, and I'll just extend this for now. Start, and I want to read this from left to right, so I'm going to start by drawing v2 first. So v2 is about that long. I want to label so I know that this is v2. And then we can see that I subtract v1 from v2. So I want to go from the end of my arrow of v2 and subtract v1. So v1 is pointing to the right. So to subtract v1, I need to draw an arrow to the left. And this is approximately that long. v1, and negative because it's pointing in the opposite direction. And what I want to do is I want to connect. So I'm going to follow my equation. I start from v2 and I end it at the end of my second vector. So we can see that this represents two things. One, this represents the change in the velocity, but it also represents the acceleration in our motion diagram. So now I want to take this arrow and place it in my motion diagram. And to do that, I want to place it over the two vectors that it's describing, in this case v1 and v2. So I'm going to place this overlapping my v1 and v2, and of course label my vector. I can do the same thing for velocity from v0 or v0 to v1. So again, I'm going to look at the difference. Acceleration between 0 to 1 is going to be v1 minus v naught. So now I want to read this again from left to right. The first one that happens is v1, so I'm going to draw v1, which is approximately this long. And then I want to subtract v naught. So v naught is pointing to the right, so I need to draw an arrow to the left. And it's about this long. Actually, it's a little too long. Let me shorten that. There we go. Negative v naught because it's pointing to the left. And again, I want to draw an arrow connecting the beginning of my equation, the start of v1, to the end of negative v naught. And again, this is going to be a 0, 1. Now again, I want to draw this arrow overlapping the two vectors that it affects, or that it's describing, which is v naught and v1. So I draw it over two of them. And again, I label. So now we have a properly formed motion diagram where the position is labeled in order, the velocity vectors are labeled in order, and we have the acceleration vectors that describe how the velocity vectors are changing. Now there's one thing that I want to point out, is that this acceleration vector, again, is the change in the velocity. So if I were to add v naught plus this acceleration between v naught and 1, I should get back my final velocity, or my v1. Same with the next one. v1 plus acceleration 1, 2 should give me back v2. So this is a good way to check to make sure that all your velocity vectors are correct.